Hello, welcome back. Today in this video we are going to see how we can get the structured output from LLMs in case of Spring AI. So while working with LLMs, we get the response in human natural language from the LLMs, and in order to convert it into our own desired data structure, we can make use of Spring AI structured output. So we can request the data in the form of Java objects as well as list, and also we can request the data in the form of maps, that is key value pairs. So how it works behind the scenes. So Spring AI makes the use of converters. We have different converters to achieve the different kind of output. What they do is, before sending the request to the LLM, they add special instructions stating we need the response in JSON format, and once we have received the response from LLM in JSON format, all these converters do is convert that response into our own desired data structure, which can be object, list or map and so on. So here you can see we have different kind of converters available. First one is bean output converter, using which we can request the data as per our own Java class or record. We can say we need the data as per own Java object. Then we have the map output converter, using which we can achieve the output in the form of key value pairs. Similarly, we have the list output converter to achieve our output in the form of list. As one simple example of it could be list of strings. So now we have some basic idea of Spring AI converter. We will jump into one simple application that we have developed to showcase how it works in real life. So first I will showcase you what all dependencies we have added in our project. So first one is Spring Boot Starter Web, which is useful for developing the REST APIs. Then we have the Spring AI Starter Model OpenAI, which is useful for interacting with the LLMs. We have added the dependency of OpenAI, but for simplicity we will make use of Google Gemini, which is free to use for our POC purpose. And then we have added the Spring AI BOM dependencies, which is useful for managing the Spring AI dependencies. Now coming to the application YML, here we have added the configuration related to AI. We are passing the API key from the environment variables. Then we have customized this. Since we are interacting with Google Gemini APIs, we have altered the base URL as per Google. Then we have configured the completion path, and the model which we are making use of is Gemini 2.0 Flash, which is free for POC purposes. So this was the configuration regarding our application. Now then we have the controller class, wherein we will be creating different endpoints to showcase the output of different converter. But prior to it, let's see the structure of our controller. Herein we have defined the base path as API social. Then we are configuring the chat client with the help of chat client builder. So what we are doing is, in order to interact with the LLM, chat client is needed, and in order to create the bean of chat client, we are making use of chat client builder. Here you can see chat client.build, which will give us the chat client instance, and using which we will interact with our LLMs. Now before jumping to the endpoints, let's see one option which is available to directly request the JSON data from the different LLMs. So some of the LLMs support the JSON output. We can request the JSON output from those LLMs. So here inside the Spring documentation, you will see some of the LLMs support built-in JSON mode, and these are OpenAI, Azure, Olama and Mistral AI. What we need to do is, we need to set the properties inside our application YML and specify that we need the output in the JSON object or JSON format. So what we will do, we will add the property inside AI OpenAI chat options, then response format, and type will be JSON object. Now when I will restart this application, this property will be configured. And coming back to the controller, this is the first endpoint using which we will see the JSON output. So we have created one simple get endpoint named as engagement. It is accepting some input in the form of query parameter. What we are doing is, for our social media metrics application, what we are telling the LLM is to generate a sample social media engagement matrix for platform that we will accept from user, and give us some metrics like share, comments and so on. So with the help of chat client, we are passing the user prompt that we have written here, and whatever input that we are receiving in query parameter, we are mapping with the help of param, and then we are calling the LLM, and whatever content we will receive from LLM, we will send it back to the user. Since we have set this property, which is response format type JSON object, what we will do, whenever the request is sent to the LLM, it will ask the data in the form of JSON. So we will see this in action. We will call the engagement endpoint. So here we have the engagement endpoint, API social engagement endpoint, and the platform that we are setting is Instagram. Now when we will send the request, the expected output is we should get the response in JSON format. So here you can see the response is received wherein likes, share, comments and reach information is shown as per the prompt that we have added. So if you see the logs, whenever the request is getting sent to LLM, there must be one parameter named as here you can see while sending the request to Google Gemini, here the response format is set as JSON object, due to which when we are receiving the response from the Gemini, here you will see we have received the response in the form of JSON string. So this is how the JSON output is received from LLM, and then we are returning it back to the user. So this was regarding the response format JSON. Now what we will do, we will comment it out, since this configuration is applied at the global level, we do not want it. So for the next examples wherein we will use different type of converters, we will see those in action. Now coming to the next endpoint, wherein we are specifically asking the LLM to give us the response as per our Java entity, which is user profile. So first we will go through the endpoint that we have created, then we will see the structure of user profile, and then we will see the response that we are getting from the LLM. So the endpoint is profile, wherein as an input we are accepting the username, and basically LLM will generate a sample social media profile for a user with the username that we have received. Again, the instruction remains the same. We are passing the user prompt, we are mapping the values that we are receiving in input, we are calling the LLM. Now here you will notice earlier we were making use of the content dot content, here we are making use of dot entity, wherein we are asking the LLM to give us the response as per this entity, which is user profile. Now if we see the structure of user profile, which is nothing but the Java record, it consists of set of fields including primitive data types like full name, followers, we have list of string as well, and then we have a nested object as well, which is social media metrics, which is another Java object which contains like, share, comments, reach and so on. So what it will do, when the request is sent to the LLM, behind the scenes it makes use of the bean output converter, which is responsible for which will ask the LLM to give us the response in JSON format. Once the JSON format response is received from LLM, it will try to construct the response as per this class, which is user profile. Now we will see this is in action. So when we send a request to API social profile endpoint by passing the username as John, now we should receive the response as per our user profile class. For example, when you go to user profile, it has fields like username, followers, following, interest and metrics, username, followers, following, interest and metrics, and inside metrics we have fields like, comments, reach, engagement rates, like, comments, reach and engagement rate. Now if you see the logs, again it will remain the same, like we will send the request to the Google Gemini, and apart from our prompt, what it is doing is it is adding certain instruction while requesting the data from the LLM. So here you can see the prompt that we have provided was only this: generate a sample social media profile for a user with the username John, post which certain instructions have been added by the converter. Here you can see it is asking your response should be in JSON format, do not include any explanation, and generate response as per this schema, and the schema is something which is as per our user profile class. So this is how, while sending the instructions to the LLM, while sending the prompt to the LLM, we are specifically mentioning that we need the response in this format, and then once we have received the JSON response from the LLM, the converter is converting the response into our own desired format, which is user profile entity. So this is how it is working behind the scenes. So this was the example regarding bean output converter. Now here you will see we have received the response as a single object. Now what if we need the list of responses or list of objects inside the response? For this we have created one new endpoint, which is /trending. What it will do, it will simply generate 5 trending topics related to the category which we will receive as a query parameter from the user. So once we have received the category, we will send a call to LLM, and then with the help of entity we are specifying in what format we want our response to be. So here you can see we are making use of new parameterized type reference, and then we are asking we want the response in this format, which is list of trending topic. Trending topic is another Java record that we have created consisting of 3 fields: topic, popularity and related hashtags. So what it will do, it will request the data in the form of this list of trending topic. The core principles will remain the same. When the request is sent to the LLM, it will ask the data in JSON format. Once we have received the JSON response, then it will try to structure as per the data that we have requested, which is list of trending topic. So for this we will call the trending endpoint. So here you can see API social trending endpoint, and category we are passing it as AI. So now what we are expecting is we will get the list of the trending objects. So here you can see the response is in list, and then we have received the response like topic, popularity, related hashtag, which is nothing but the structure of trending topic. It has topic, popularity, related hashtags, and so on. So this is how the list of objects we can request. Now here you will see we have mentioned it as new parameterized type reference. Behind the scenes it is making use of bean output converter only. So this is how the responses are getting converted. Now we will see one more example related to list, wherein our response is simplified. In our earlier scenario we were asking for list of objects, but what if our response is quite simple, like we only want the list of strings. So for this we have created one new endpoint, suggest keywords, which will ask the user for certain topics, and based on that it will suggest 5 to 7 relevant keywords about the topic. So again we are making use of chat client, we are passing the user prompt, we are calling the LLM, and then we are requesting the data with the help of list output converter, which is nothing but the converter which is responsible for converting the response that we have received from LLM into the list. So when LLM sends us the response, what it gives us is the list of comma separated string. What it will do, it will split those string and send the response as per the list of strings. So let me showcase you by hitting this endpoint, suggest keywords. So we will hit our API social suggest keywords with topic as AI. Now we are getting the response in the form of list of string, which is expected, but behind the scenes you will notice that when the response that we are getting from LLM will be the list of comma separated string. Let me just see this, just a second. The response that we have received here, yeah, here you can see we have received one response, and it is a single string and the values are comma separated, like AI technology, artificial intelligence, machine learning, and so on. So this list output converter is responsible for converting the comma separated value in the list of string. So this is how it is working behind the scenes. Next I will showcase you two examples. Now we have seen simple JSON response. We have seen how we can request the data as per our Java class. We have seen we can request the data for list of objects as well as list of string. Now we will see two examples related to the key value pairs using map. So for that we have created one new endpoint, which is campaign summary. We have defined the user prompt. What it will do, basically it will provide a summary for the social media campaign based on the input that we are receiving from the user, and it will provide the summary for the different social media platform like Twitter, Instagram, and so on, and it will try to include these metrics while giving us the response. So the core logic will remain the same. Using chat client we will call the LLM, and with the help of entity we will request the data. Now while requesting the response from LLM, here we have specified the map output converter, which is responsible for converting the JSON response into the key value pair. And in our case we are expecting the response in this format, which is map of string of object. So when we send the request to the LLM using campaign summary endpoint by specifying the campaign name as AI, then we should get the map of objects. Here you can see for Twitter, Instagram, and Facebook, which are nothing but the map keys, and we have received that our desired matrix, which is nothing but the object. So it is a map of key and objects. Here we have specified map of string comma object. So it is a map of string comma object, and the matrix that we have requested as per our prompt are sent by the LLM. So behind the scenes the core logic will remain the same. It will request the data in JSON format. Once we have received the JSON response, the map output converter is responsible for converting the response as per this requested structure. Now coming to the last endpoint, which is related to map of key value pairs only. The only difference is now instead of using the map output converter, we are requesting the data with the help of new parameterized type reference, and then we are specifying that we need the data in this format, which is map of string of object. So as an input we will receive the brand from the user, and with the help of LLM it will analyze the sentiment for the brand for the different platforms like Twitter, Instagram and Facebook. So now when we send the request, we are specifying the brand name as Tata Trust. So we will get the desired output in the form of key value pair for different social media platform. So here you can see the key string, which is Twitter, Instagram and Facebook, and the value is the object containing different sentiment related info for the brand Tata Trust. So this was all regarding the structured AI output. The details that we discussed during this tutorial, all details are mentioned inside the blog. Also the example that we discussed is also commented on the GitHub. So the only difference is, in order to enable the logging, what we did was we added one additional dependency of logbook, and we have specified the configuration, which is printing the request and response. So for logbook, we have created a separate blog on our website. You can go through it to see how we can enable the request and response for LLM. I hope this tutorial was useful. Yeah, that's all from my end. Thank you.